Morning, everybody. We're going to continue our look at statistics today, and mainly we're going to be looking at outliers, and we're going to be looking at cumulative frequency graphs. So, if you're following along in your textbook, we're going to be looking at 12G, and we're going to be looking at 12I, and we will go from there today. So, the first thing that we're going to be talking about is going to be outliers, and up to this point, we've considered an outlier just data that is either too low or that's too high, and it is sticking out from the other types of data for whatever reason in particular. And so we've eyeballed them, but today we're going to actually look at what it mathematically means to be an outlier. So it's all in relation to those quartiles that we were talking about. And so basically you have two types of outliers that can occur. We have an upper boundary, which is when we do the upper quartile here, which is the Q3, plus 1.5 times the IQR. If a number is greater than the upper boundary, we say, okay, it is a high outlier. We have the lower boundary here. I forgot the Y right there. Let me write that in, which is just that you take the lower quartile, you take the Q1, and instead of adding the 1.5 IQR, you're subtracting it because we're trying to see if it's a lower number. So we're going to look at an example here. So this is example 9 on page 327 out of your red book. And so basically what we're going to do is we want to look at a data set and we want to determine mathematically, are there any outliers? So in order to construct outliers, I am going to have to figure out my quartiles because I also have to figure out my IQR. So I've gone ahead and organized this data in order so that you all don't have to watch me organize data for whatever amount of time. So we can go ahead and get going. So let's see here. How many terms? I believe that there are 20 terms in this data, which means that the 20 plus 1 over 2 term, we're looking for the 10.5 term. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And lucky for us, so in between 10.5, that median is going to be 8. So 8, we'll just say the median equals 8 here. So now we've got to figure out the quartile 1 and the quartile 3. So then let's see here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers now. So we're going to look for in between the 5th and the 6th term. So here, the quartile 1 is going to be 6.5. And then for this other data set here, we're going to go 1, 2, 3, 4, 5, 6. It's going to be in between these. We're going to say that the quartile 3 here is 10. Now, it does want us to construct a box plot for this data, so we will need the max here of 16, and we will need the min here of not 16, it is 1. So now when we're constructing this box plot here, let's see, we'll say 0, and I'm just going to go by 4s. 8 and 12 and 16. So we've got that. Our box starts here. The median goes through it. The Q1's like 6.5. So I'm constructing this box plot right here. We've got 16 is the max here. And then the min is 1. So let's see, like right there. And so up to this point, this is how we construct a box plot. But what we have to do now is we have to check and see, okay, does this data, does it have any outliers? So the first thing before we can do anything is we need to calculate what the IQR is. So that's just the distance between your quartiles. So in this case, it's going to be 10 minus 6.5. So our IQR is going to be 3.5. So now for these outliers here, what we've got to do, what we've got to check is the upper boundary and the lower boundary. So I'm just going to write UB for upper boundary. So that's the upper quartile here, which is the quartile 3. So we're going to say 10 plus 1.5 times 3.5. And I'm going to get that the upper boundary for this, based off of that, is 15.25. So the upper boundary right there is 15.25. Any number that is above that in that data set is considered an outlier. So like for example here, 16 would be considered an outlier because it's above our upper boundary. So then for the lower boundary here, we're going to do 6.5 minus 1.5 times 3.5. And if you evaluate that, we're going to get that the lower boundary here is 1.25. Now, whenever you're making your box plot here, if you've evaluated it and you have found your outliers, you don't include them like you would normally. So like this box plot right here is the box plot that we would normally make, but we're going to have to make a different box plot now that we know that there are outliers. Because when you have an outlier in a data set, you do not include it in your box plot. What you do is you just put an asterisk where they're at. So since 1 here is an outlier and since 16 is an outlier, I'm going to go to that spot in my box plot and I'm just going to put an asterisk. And so then I'm going to start my min here from 3. And then everything else is going to stay the same. So same thing over here. 16 isn't going to be my max anymore. That's considered to be an outlier. We're going to use 14 here, and then we're going to draw the rest of this box plot here. So over to 6.5, median of 8. And then the Q3 is at 10, so halfway. So this would be considered, now that we have this knowledge of outliers, this is considered to be the correct box plot, because if there are outliers, you do not want to include them in your data set, although it's valuable to understand that there are outliers. The whiskers here on this box plot don't include those. Because if we're trying to look at percentages of people, outliers can really throw off some of the numbers that we're looking at, so we don't include those in our box plot. So that's kind of a little bit of a sample on how to find outliers. If you all have questions on that, please let me know. The second thing that we're going to look at here is we're going to look at section 12I, which is cumulative frequency graphs. Now, we've talked about cumulative frequency just a little bit, and basically, if you want to know the number or the proportion of scores that are above or below a particular value, you're going to use what's called a cumulative frequency graph. So just a little bit of vocabulary that we need to cover before we get going is this word called percentile. Percentiles basically tell you the score below which a certain population or a certain percentage of data lies. So chances are you all have taken the ACT, and if you're like me, you wondered why it is not just on a scale of 1 to 100 like most tests that you all take are. And so if you look at your scoring, whenever you get your scoring report back, percentiles actually do that. They look at the amount of people who scored above or below your score, and they create these percentiles because humans can understand percentages better than they can just raw data. So like the way that you would interpret this, so if you're like the 85th percentile, that's the score that 85% of the data lies below. So like if I was in the 85th percentile for height, that means 85% of people would be shorter than me. Or if your score here is in the 95th percentile, we'd say, okay, well, 95% of the class scored less than your score right there. And so a couple things to note here. The lower quartile is the 25th percentile. And you think about that because you get that by taking half of a half. So if you take something and cut it in half and then cut it in half again, you will just get a fourth, which is 25%. The median, the Q2 here, is the 50th percentile because if you cut something in half, what percent is that? Q3 is found similarly to Q1. You're adding a fourth to Q2 though. And so we're going to use this information and kind of look at these cumulative frequency graphs. So and if you look here, the handwriting gets a lot better. My wife helped me out with writing down the rest of these notes. So shout out to her. So we're looking at example 11 here from page 332. And so basically what these are is that this is the results of the women's marathon at the 2008 Olympics in good old Beijing. And we're going to create a frequency table for this, or the frequency table has been provided, but we're going to turn this into a cumulative frequency. So as a reminder, the way that we do cumulative frequency is that we're just adding frequencies. So if this frequency is 8, we don't have anything to add 8 to. But on the next one, if t is between 148 and 150, the cumulative frequency, we're going to do 8 and 3 to get 11. We're going to add 11 and 9 to get 20. And basically, we're getting how many people were this time or less. So 20 and 11 is going to give me 31. 31 and 12 is going to give me 43. 43 and 7 is going to give me 50. 50 and 5 is going to give me 55. 55 and 8 will give me 63. 63 and 6 will give me 69. So the next thing that we need to do is we need to graph this. We're gonna graph these cumulative frequencies here. So whenever you're graphing cumulative frequency, I've got my graph drawn on a different chart here. So let's see if we can make this work. I think we can a little bit. So all the way up until we get to 148. We hit 8. So what we're going to do is we're going to start at 146 here. We're going to start from 0. And then at 148, which on the graph I've got here, we're going to move over here. We're going to go up to 8, and we're going to plot a point there. So then the next one that we're going to plot is over, if we look at this for 150, the cumulative frequency of people who have made it to 150 or less is 11. So I'm going to plot 150 and then up to 11. And that's kind of the blueprint for how you graph a cumulative frequency one. So then for up to 152, the amount of people that finished in 152 or less is 20. So I'm going to go to 152 and 20, and I'm going to mark that coordinate. And so on and so forth. So 154, I'm going to go to 31, put a coordinate there. Then I'm going to go, excuse me, I'm going to go to 156 and plot 43. And then I'll go to 158 and plot 50. And then I'll go to 158 and plot 50. We'll go to 160 and plot 55. And then let's see, it goes, we make a big jump here out to 168. They are 63, so these are the people who we're not up with that lead pack in this race. So let's see, 63 is right there-ish. And then 176 at the very end here was 69, so all the way up here. So once you've got all of those points graphed, we want to connect those, and it's going to be an interesting looking little graph here. So let's see. And they're not always going to look the same. But for right now, this is the cumulative frequency graph that we have for the data that we've been given. And so we want to answer some information about this from this data here. So the first thing it wants us to find out on C here is it says, what is the median finishing time? How the middlemost person here, what did they finish at? So the whole point of constructing that graph is, so if we had, I think it was what, 69 people? So if we had 69 people, the median, remember, we said percentile is going to be times 0.5. So we're looking for where the 50th, or I guess for the 34 and a half person, or technically you could do the 35th person and that would work. We want to know what was their finishing time. So once we know that we've got 34 and a half, where thereabout that we're looking for, we're going to go over to that place on the axis and kind of just draw a line here over to where we intersect, and then we're going to have this go down to this axis right here to get a general idea. So depending on where you intersect at, you could say, and these are going to be approximate because my graph's not perfect, your graph may not be perfect. To me, that looks like it's about right here, that's about 155 minutes, which is a pretty quick marathon. That's like, I want to say that's like 6-minute miles the whole way. That's scooting pretty good for 26 miles. Just running 6-minute miles. So then the next thing that we want to answer here for C is we want to know the number of competitors who finished in less than 155 minutes based off of this information right here that we've been given. So if we go to 155 and we look, that to me, so let's see, less than 155. If we go and we draw that line again, that's going to be give or take right about where the median is. Give or take right about where the median is. So to me, that looks like it's going to be approximately 35 runners. And again, whenever we're doing problem sets with cumulative frequency graphs, if you are a number off, like if you're like, Mr. Price, I have 63 and 64, is that okay? We're creating a graph based off of, and we're connecting these points with approximations. It is perfectly okay if you are a little bit off. So the next thing that we're going to look at is the percentage of competitors above 159 minutes here. So if I'm looking for 159 on this cumulative frequency chart, 159, 160 occurs right here. So I'm going to do my best to draw a straight line here up to right here. So the amount of competitors here that are going to take more than 159 minutes. So that looks like that's intersecting. Let me try to draw a straight line from here. So there's 52, that looks like it's about 52 or 53 to me. We're going to call it 52 here. So in total here, there are 69 competitors because that's the total cumulative frequency. So if we got to 52 here, then we'd say, okay, how many are left? 69 minus 52. That's going to be 17 out of 69. It'll be 17 out of 69. And the percentage there is approximately 24.6%. So then the last thing that we want to use this graph to find is we want to say, okay, if you finish in the top 20%, what time did you run? And I don't know why I labeled this with 3 again. I'm going to turn that into a V. There we go. So again, we need to ask ourselves, okay, if you're in the top 20% of people here, what finisher would that be? So we'd say 69, the amount of finishers times 0.20. And let's see, that's going to give me 13.8, or we're going to round that up to 14th. So if we're looking for the 14th person here, we're looking for the highest finisher here. So we're going to look for, if you're in the top 20%, we need to look for the cumulative frequency of 14 here. So give or take, right below 15 here, I'm going to draw a straight line. And this right here, between 150 and 152, to me looks like it's 151. So the top 14 people here finished in 151 minutes or less. And so the thing about cumulative frequency is that they can be a little bit confusing sometimes. And it usually takes a little bit of getting used to creating the graphs and as far as interpreting them. So I want to do one more example with you all, and then we will call it a day for today. So the other example, we're going to do number 2 out of your all's textbook. This isn't an example per se. It's just a problem I pulled from that textbook. So we've got the heights of seedlings, and we have got these presented in a cumulative frequency graph. And so we want to use this graph to answer some different information about this. So the first thing we want to answer is, okay, how many seedlings have heights of 5 centimeters or less? So if we're looking at the height here, 5 centimeters occurs here. And so if we draw this line over there, we're like, okay, we're going to ballpark this. We're going to estimate this. How many is that? To me, that's either 8 or 9. It doesn't matter which one that you say. We'll say 9 plants. So then the next thing we want to know is, okay, what percentage of seedlings are taller than 8 centimeters? So if we go over to the height of 8, and we go and check at what point that is, that occurs at, that looks like it's about 43 to me. So the total amount of plants here is 60, because that's where the cumulative frequency ends. So our denominator is going to be 60. But the numerator, we want to know how many plants there are between this point and this point. So 43 and 60, the distance between those is 17. So then if we get 17 out of 60 as a percentage, I believe that's going to be pretty close to 28 point something. I'm not quite sure what the point something is going to be, but I feel fairly confident in the 28 part. If it's not correct, you all can let me know. I'm just using my phone to record, so I can't pull up the calculator right now. So then the median height that we're going to be looking for here, if we're trying to find the median height, we're looking for the 50th percentile here. So we're going to multiply 60 times 0.5. So we're looking for the 30th seedling here, the 50% mark. And so if you go to 30 here and you draw a little line here and then you draw it going down, that looks like it's going to occur maybe just a little bit past 7. Maybe just a little bit. You could call it 7 and I wouldn't gripe. But we're going to say approximately 7.1 centimeters for that height. So then another thing that we're going to do here is that we're going to find the interquartile range for these heights. So what we've got to do is say, okay, well, we need to figure out where on this graph is Q1. We need to figure out where on this graph is Q3. And then we need to subtract those heights. So Q1, as a reminder to you, is 25%. So for Q1, we're going to do 0.25 times 60. So a quarter of 60 is 15. And we're going to look on this graph, where does 15, what height does the cumulative frequency of 15 go to? Excuse me. So to me, that looks like it might go a little bit past 6, maybe just a little bit. Actually, no, it's a little bit under 6, excuse me. So if you draw a straight line from 15 to here, you hit it just a little bit before it. So we're going to say that's a height, we'll say 5.9 for Q1. That's the height that responds to 25% of the data is below this. So then for Q3, we're going to do the same thing, except we're going to do 75% times 60, which is 45. So we're going to go to 45 on this graph, and we're going to look for when these things cross. So to me, just eyeballing that looks like it's going to be, so our first one was 5.9. To me, that looks like it's going to be like 8.3, 8.4-ish. So that height for Q3 is going to be 8.3. And then all that we're going to do is that we're going to subtract these two things right here to get the IQR. Because this is our Q1 height, this is our Q3 height. So 8.3 minus 5.9 is going to give us about 2.4. So I'm going to circle that one. And then the last thing that we're going to do for this problem, we're going to find the 90th percentile for the data, and we're going to explain what this value represents. So again, for 90th percentile, we're going to multiply 0.90 times 60 because we need to know what number plant is going to match that for us. So 90% of 60 is 54. So what we're going to do is we're going to go over to 54 here. We're going to draw a line over there, and it actually ends up intersecting 10 perfectly. So the 90th percentile for the data point here would be 10 centimeters. It's the height there, and what this value represents is that if your plant is over 10 centimeters, then it's taller than 90% of the plants. If your plant is 10 centimeters, it's taller than 90% of plants. Which you'll see percentiles used a lot, like with really young children. Like if you all know a newborn, they'll be like, oh, my kid is 83rd percent for head circumference and 65th percentile for weight and 82nd for height. But they're an easier way to quantify things rather than like talking specifically in a field. Like with plant height, like I don't think anybody in this class is an expert on plant height. If you are, I will be impressed. But it's easier to understand, okay, this guy is in the 90th percentile or this plant is in the 90th percentile rather than just talking about the numbers specific to that field. So that wraps it up for the day. If you all have any questions at all, please let me know and we will go from there. Thanks, everybody.